Good evening, one and all. So today we'll derive the expression for self-inductance of the cable by using Biot-Savart law and obviously Ampere's law. In fact, Ampere's law. So now suppose consider a cable having inner radius A and outer radius D. So this one. So this is having inner radius A and outer radius B. So this one is A and this one is B. Now, as I have told you, for Ampere's law, we have to imagine, you have to construct an imaginary Ampere's law. Suppose this is at a distance R. Now construct take an imaginary area over here. So this will be ds and this will be dr, because the variation in this along the direction of R, and this one is dz. So the area vector will be, that means it will be, the direction will be normal to the plane. So it will be along the phi direction. So now I can say B vector is equal to E magnitude and it is along the direction of phi, so it will be A phi. Now ds vector, it will be dr dz A phi. Now as we know that the flux is represented by d phi, and that is the dot product of B dot ds, and it will be, this is the surface integration, this will be the surface integration, it will be the scalar product of B and ds. B is the flux density and ds is the area vector, and if we substitute the values, it will be B A phi dot dr dz A phi. So as you know that A phi dot A phi, it will be 1, so I can write this one is, so d phi, in fact it is integration of d phi, that will be phi, so it will be B dr dz integration. This will be surface integration, means double integration, as the variation is along r direction and z direction. Now I can write this one is mu h, or I can take, if the medium is air, then I can write this will be surface integral of mu 0 h dr. So I can take this mu 0 outside because it is a constant, and this is h dr dz. Now we have already calculated that by using Ampere's law, h is given by I by 2 pi r. That's what we have calculated. So it will be I by 2 pi r, I by 2 pi r dr dz. So this will be again surface integration. So phi will be given by mu 0, this one is mu 0, and it will be 2 pi, you can take outside, and it will be I dr dz. Now this dr dz, the variation of r is from A to B, and suppose we are taking the height as 1 meter, so dz will be varying from 0 to 1. So meter, it is unit, we are taking unity. So now f phi is equal to mu 0 I by 2 pi dr dz. Now you put the limit. Now phi is equal to mu 0 I by 2 pi. So dr, if we put the limit, so it will be dr, sorry, it is dr by r, so it will be ln r. So you put the limit, it is from A to B, and this is dz, integration of dz will be z, and if we put the limit, it will be 1. So 1 into this one is 1, so I can write this one is mu 0 I by 2 pi, and if we put the limit, it will be from, it will be ln b by a. So now we know that the self inductance is given by n phi by I. So it is equal to n, suppose you are taking for one term, so it will be mu 0 I divided by mu 0 I by 2 pi ln B by A divided by I. So I get cancelled and it will be Henry, it will be in Henry per meter. So this will be mu 0 I by 2 pi ln B by Henry. So this is the inductance calculation, and based on this we will be doing a problem. Suppose it is given that the length is, suppose the length of the cable is 100 meter. Suppose the length is 100 meter, that means Z is 100 meter. So you can say the limit of Z will be from 0 to 100, and the inner radius and outer radius are, that means A is equal to 1 millimeter and B is equal to, suppose this one is 7 millimeter. Now how to calculate this one? So as you have calculated that this one will be L is equal to, so this will be mu 0 I divided by mu 0, L will be mu 0 by 2 pi, not I won't be there because already I get cancelled. So it will be mu 0 by 2 pi, and we can say it will be from dr to r, and this will be from dz to z. It will be from dz, it will be dz, and z varies from 0 to 100, and this one is varying from 1 millimeter to 7 millimeter. So now the value will be mu 0, you can put the values 4 pi into 10 to the power minus 7 divided by 2 pi. So it will be ln r, and it will be 1 to 7, 1 millimeter to 7 millimeter, and this one will be 100 because the integration of dz will be z and it will be 100. So now it will be 4 pi, this will get cancelled. So 2 into 10 to the power minus 7 into 10 to the power 2, and this one will be ln 7 by 1. So whatever will be getting, that is the value of the inductance. So you can write this one is 2 into 10 to the power minus 5 ln 7. You can calculate by use of the calculator. So this will be coming around 30.9 micro. So this one is the self-inductance of the cable. In the next class we will be discussing about energy stored in a magnetic field, and we will be discussing about the energy density. So thank you all for watching. Please like, share and subscribe to my channel. Thank you all.